Hi class, we're looking at lesson 5.2, the function. If you look in your notes, you can find and follow along on page 6. Please make sure you've check the skills you'll need. We're going to be identifying functions and relations and evaluating functions. So the first thing we need to do is go through a few definitions. A relation is a set of ordered pairs. So like x comma y would be an ordered pair. And so a set of these. So you have a bunch of ordered pairs. You have a bunch of x's and y's paired up. A function is a relation that assigns exactly one output range value for each input domain value. Okay? I think we talked about domain and range a little bit in chapters 1 or 2. But so it assigns exactly one value of the output. Okay, so 1x gives you, if you take and you put in 1x, it's only going to give you one y. It's not going to give you two different y's. Okay, that's what makes a function. A domain is the input value. So that's going to be your independent values, your x values, and the range are your output, your y value. So domain, range, input, output, x, y. Commit that to memory. A vertical line test is the easiest way to tell if a relation is a function. And again, a relation is just a set of ordered pairs that we have. And if the vertical line test, okay, so if you make a vertical line and it passes through more than one point on a graph, then for some value of x there's more than one y, therefore the relation is not a function, it's just a plain old relation. Okay, and then a function rule is an equation that you can write to describe a function. Note function notation when you use f of x to indicate the outputs. Okay, we use x for the inputs and then f of x, which is kind of like y, for the outputs. Let's look at a few examples. All right, so here we have a set of values. Okay, so we have our x's here, and here's our x and here's our y. So this is right now is considered a relation. We have a set of values, ordered pairs, and what we want to do is we want to look at all of the x's and we put them into one column. So here's my x's. We then put all of my f of x's, or the outputs, our y's, in the second column here, all the different ones. Now what you want to do is in order to map these, let me get a different color here, let's use red. So here for my 4, it will give me the answer of 3. 2 will give me -1. -3 will give me -3. Then this last point here, this last 2, notice this 2 also gives me a 4. So this does not follow the rule that for every input, okay, it gives you one output, because in this case we've just shown that the 2 will give us 2 different outputs. So this is not a function. If you were to graph these and use the vertical line test, the points 2, -1 and 2, 4 would be lined up right on top of one another and would fail that vertical line test. Let's move on to example 2. You may want to take a minute to pause the video and plot these points: 0, -2, 1, -2, -3, 1, -2, 0, -1, -1, 3, 2, and 2, -3. Okay, and we're going to use the vertical line test here to determine if it's a relation. I've placed stars on all of those points there. Okay, you may need to take a minute and plot those points. You can go ahead and pause me now. And then once you're done, start it back up. And notice here, let's just grab a nice red line here. There is no one spot on this graph in which if I drew a vertical line, I would hit 2 stars. Okay, there is no one spot there. So guess what that means? That means this is a function. Function. Okay? So this right here, this set of values, this relation is a function because none of the independent values have more than one dependent value attached to it. Okay? Moving on to example 3. Example 3 says make a table of a function rule. Okay, so here's our f of x. Here's our function rule. Again, f of x is a fancy way of saying y. And they want us to use the domain. Remember, domain is the input. So they want us to use -2, 0, 2, and 4. So we're going to put in -2. Remember, domain is input. So we put in the x, which is -2, and we have -5 times -2. That gives me a positive 10 plus 25 gives me 35. I'm going to plug in 0. 0 times -5 is 0 plus 25 gives me 25. Let's plug in 2. 2 times -5 is -10. -10 plus 25. -10 plus 25 is 15. And then let's move to 4. -5 times 4 is going to be 20. -20 plus 25 gives me a positive 5. So here is a table of values, okay? Don't shortchange yourself when you're making a table of values. Take the time. So here is our domain, which is our input. Here is our range, which is our output. If it asked us to use domain and range notation, you would put the range in like this, into a little set of fancy brackets, okay? And then here's our domain, which could also go into another set of fancy brackets. Okay, so we've got domain and range. Now here it says find the range. Here's our function rule, and here's our domain. So we're going to do the same thing. This asked for a table of values. This one gives us a domain, so technically we should use, it gives us that fancy domain range notation. Okay, so here's our domain, which is -1, 3, and 5. And so our range is going to go in another set of little fancy brackets. Okay, -1. Plug in the -1 for G. We get -2 times -1, which is a positive 2, plus 4. 2 plus 4 is 6. Plug in 3. 3 times -2 is -6, plus 4 gives me a -2. And then 5. 5 times -2 is -10. -10 plus 4 gives me -6. So here's my range. Here was my domain. Here's my range. It's given my input, my output, domain and range. All right, moving on to, quick check time. You'll do that in class tomorrow. Short lesson. Good luck. I'll see you tomorrow.